clear at 4 meters but blurry at 10 meters? That sharpness gap is a safety risk. Today, we're breaking down standardized depth of field testing for CMS regulatory compliance. So, why is 4 meters sharp while 10 meters is a blur? The root cause lies here. The circle of confusion. Take a look at this diagram. When a point isn't on the in-focus plane, like objects in the foreground or background, it doesn't hit the sensor as a dot. Instead, it projects as a blurry spot. That's the circle of confusion. And depth of field? It's the range where these blurry spots from out-of-focus points are small enough to still look sharp. In photography, the circle of confusion is defined by what the human eye can distinguish. But for CMS, we use MTF10 to measure if the circle of confusion is too large, which would mean the resolution fails to meet standards. According to ISO 16505, MTF10 is tested at 3 distances, 4 meters, 6 meters, and 10 meters. MTF10 1:1 is the spatial frequency where the modulation drops to 10%, under 1:1 native display conditions. The standard defines 10 meters as the far reference, 6 meters as mid-range, and 4 meters as near-range. At 10 meters and 6 meters, the target is 90% of the MTF10 min 1:1 baseline. At 4 meters, it drops to 50%, since close objects appear larger on the display. How do we get precise data? You need hardcore gear. For this test, we used Yanding's automated CMS testing system to evaluate the resolution limits at 3 key distances. The core setup includes: first, regulatory compliant depth of field test charts. Second, a motorized rail that precisely simulates 4 meters, 6 meters, and 10 meters distances. Third, standard lighting that simulates a range of color temperatures and illuminance values. Fourth, RIQA analysis software, featuring regulatory compliant algorithms. Want to see the full workflow details? Scan the QR code to visit the Yanding knowledge base.